Morgen. Entschuldigung für die kleine Verspätung. Ja, mit dem Mac geht es immer ein bisschen schwieriger. Könnt ihr immer noch die Türe zumachen, bitte? Wäre das möglich? Vielen Dank. Ja, im Ende September wurde Buildship als Teil von Eclipse Mars.1 ausgeliefert. Im Simultaneous Release und auch in den wichtigsten Distributions, Java Committer, Eclipse Committer, Java Developers, Eclipse Committers.
This is an English-speaking conference.
Sorry, yeah, I can change to English. Yes. I'm not sure why even I started in German. I guess because I talked to these guys. All right, so let me start over again. In the end of September, we released Buildship as part of Eclipse Mars.1. So we're part of the simultaneous release now, and we are included in some of the distributions you can download. The one for Java, the one for the Eclipse committers, and the one for RCP. And more are coming up. I think Xtext also wants to be including Buildship. All right, but before we get started, and before I give you some more details on Buildship, who does not know what Gradle is? Everybody knows. That is good. Last time I gave a presentation, and at the end of the presentation, somebody came to me and complained I didn't explain what Gradle is. Like I didn't ask him why he came to my presentation, but anyway. So some questions to get started. Who is actually using Gradle in one of the projects? Okay, let's say just a few hands, maybe 5 people. Okay, so I have some convincing to do here. Who of those that is using Gradle is also using Buildship? Okay, a few of those that use Gradle as well. Excellent. So, to summarize, what is Gradle? It's a mouthful, but still, it's a modern open source polyglot enterprise build automation system. Right? Okay. And what do I mean by that? I'll come back to that in a second. Because it's more than just building something. Those that are Maven, we often get that question, why should I move to Gradle? I'm not going to do any convincing here. But if you're interested to migrate, there's a long post that describes how you can tackle such a migration. Yeah, let's start with a quiz, at least for those that already use Gradle. I have 2 questions. And you can also think, how would you solve these problems with another build system? How can you force the build system, in that case Gradle, to rerun the tasks even if they haven't changed? Right? Gradle is very smart. It doesn't run something if the inputs and the outputs have not changed of that task. But you still want to run it again for whatever reason. How would you do that? Okay. I'm going to give the answers really quickly so we can move on. You can just say rerun tasks. And all the optimization that has been in place to find out if something needs to be run is kind of ignored. Okay. I have one more question. Let's say you have a task X and a task Y, and you want to run one task after another one, or sorry, before another one. It doesn't matter which way you go. How can you tell that Gradle? How do you tell that a build system? And there is not necessarily dependency between those two. That's the point here. Right? You have A, you have X, you have Y, and you for some reason want to run X before Y. Let's say you want to run check style before findbox. There's no dependency between those two, right? And if you model it as a dependency, you're modeling something that isn't really a dependency. So how would you do this in Gradle? You can say task Y must run after task X. This is not a task dependency, but it tells Gradle, okay, I have 2 tasks, I want to run this one, I have to run this one, and then I must run this one. Okay. This is important if you think about like parallelization. If you have task dependencies, Gradle knows to run one task before another, or one task after another. But those things that are decoupled from each other, you can still run them in parallel, and that would be one way to do it. Okay, just a few things on the background of Gradle. So what is the build today? It's more than just taking some source files, creating class files, and creating a jar file, and you're done. Right? That was maybe 15 years ago when you would go to the command line and you would write by hand something like Java C or so. Today you do more. You compile, you generate code, you package stuff, you have external dependencies, you have internal dependencies. You want to enforce some company standards. There's all kinds of stuff going on. You have your custom logic, etc. So all this needs to be mapped to a build. And that's what Gradle is achieving. And it's not just about Java, it's about different languages. Whether you're building C++ or iOS applications or front-end applications or Android applications, you want to have a build system that embraces all of them, right, with the same concepts. And that's what you get when you use Gradle. Just to give you a concrete example, LinkedIn, so they have like 2,000 developers, and they're all building everything with Gradle. Right? And they use different languages, and they have different teams. They build about 2,000 components, and they do about 300,000 builds per week. Right? So pretty large scale. And about 1,000 releases per day. And so the thing to keep in mind is you have all these different components, and it all needs to be assembled and coordinated. And for something like that, Gradle is a good build system. Many people are using it, or many companies, I should say, are using it. Some of them have a white space because we cannot list them here, but they would be pretty nice to show. And if you look at the adoption, like in September alone, we had more than 1 million downloads of Gradle. Right. So you can see also from this stat, not only are people using Gradle, people are really excited to use and learn about Gradle. That was done by Jay, the zero turnaround guys, some while ago. There are also books around Gradle, so if you want to learn more about it. And I'm just showing these things to kind of give you a bit more evidence that Gradle is not just another niche build tool. It's really, it has basically become the standard. Okay, so let's look at the IDE integration before I'm going to demo stuff, because we're not just building a plugin, adding some features here and there, some checkboxes here, some text fields there, and we're done. We really have a vision behind it, which also explains why sometimes something might take a bit longer than you would expect, but we really want to follow that vision and not make any compromise on it. Okay, so for one, we want to make Eclipse more powerful. And when I say that, of course, it sounds a bit provocative, but really, it's about allowing you to do more things from within Eclipse, which means it makes Eclipse more powerful too, right? If you don't have to leave the IDE, because you can do more from within the IDE, then that makes you a more effective, more productive developer. And we want to do this in a way that deeply integrates into Eclipse. So when you do something in Eclipse, you shouldn't really know anymore if it's something that is run by the Gradle build system or if it's something run by Eclipse. The other aspect of those two is to have a single truth of build logic. That is really important. The build defines really, or contains all your logic how to build, and everything is derived from that. Right? If you look at other integrations with other build systems, they take what the build describes, or how the build is described, and they reinvent that same logic and map it to their IDE. With Gradle it's different, and I'm going to show you some details in a second. But really we want to have only build logic in the build, and everything is derived from that. Okay. So if you want to know how to configure your project in Eclipse, the Buildship plugin is not going to parse your Gradle build scripts. That would be kind of a duplication of what Gradle already does. It just asks Gradle, what is my project configuration, and it will map it to Eclipse. The other one is if you want to run some tasks or some tests, you just call an API and say, please run this task, please run this task, and Gradle will take care of it. There's no logic in Buildship that knows, oh, okay, I find the sources here, now I need to do something with them. Right? Same would be true for up-to-date checks. You want to check if some files have changed, we're going to do that. We're not going to do this in Buildship, we're going to do this in Gradle. And Gradle will tell Buildship, oh, this file has changed, do you want to recompile or whatever. Okay. So, to look at it in a bit more technical perspective, we have Gradle at the core, that's where our build logic is. We have you as a developer in Eclipse that interacts with Buildship primarily. And the way Buildship communicates with Gradle is through the tooling API. This is a little 2 megabyte jar file that acts as a proxy. And it communicates with Gradle through inter-process communication. So totally isolated processes. If you interact with Gradle from the command line, it's basically the same thing. Well, we have a launcher, but we could as well use the tooling API. If you're a continuous integration server, same thing. The logic is always just in one place. Okay. So this tooling API, as I said, it's a proxy for embedding Gradle. And not only can you use it to talk to Gradle and get information, you can also hook in some custom information if you wanted to. So if you wanted, like the Android guys, they have their own model that is hooked into, and then they can ask for that model through the tooling API. Okay. So all that is in Buildship is this little 2 megabyte jar file, which makes Buildship as a whole feature, a whole plugin bundle, really small. Okay, what does that give us to finish this topic? It gives you forward and backward compatibility. So Buildship might be using Gradle 2.8 tooling API, but you can still invoke a Gradle build that is on 1.0. That's going to work. Or Buildship could be on 2.8 and you're going to invoke a build that is on 2.9 RC1. That's going to work as well. All right, so this backward and forward compatibility is taken care of by Buildship. You might not get all the features because the 1.0 release of Gradle will not provide all the information that is available in 2.8. But the information that is available will be exposed to the tooling API. You get the runtime isolation. As I said, if we had a leak in Gradle or a leak in Eclipse, it's not going to affect the other side because it's a different process. We also provide some high-level services to the tooling API, and I'm going to show them in practice in a second. That is like build cancellation. You can cancel a build, and it's not just going to kill the process. It's really going to be very fine-grained and say, okay, you want to cancel the build? Let me see where I am right now in the build. And then it says, please stop here, and it stops gracefully. There's also continuous mode, which means the Gradle build keeps running even when the build is over. And as things change on the inputs of the tasks, it will rerun those tasks. I'm going to show that as well. We can also do test execution. So if you run your tests, maybe unit tests, it doesn't matter if you run them through Eclipse or not, but if you have integration tests, usually you have some fixture, some setup that you need to do, and some cleanup that you need to do afterwards. And so you don't want to duplicate that in your IDE, but you want to run the test through Gradle, and Gradle will make sure that the correct tasks are launched first to bring up a server, shut down a server, for example. And there's an event model. You're going to see that as well. So we have a lot of events that happen during the build, and we expose them to the tooling API, and you can see them in Eclipse visually. So you know what's going on. Oh, it's in the configuration phase. execution phase. It's now doing the task graph, or it's now running some task. It's running the test task. What test task is it running, or what test is it running? You're going to see all that. Okay. So a very powerful concept of the tooling API that we have here. Okay. So with that said, let me do a little demo. Okay. What I have here is imported is a project, and I'm going to do another import in a second. There's just a few things I wanted to show you. So one is if I run a build, I can cancel that build. So I can say cancel, and that will really tell the tooling API, please ask Gradle to cancel the build, and it's going to cancel the build at the earliest possible moment. Okay. The other thing you can see as I run this build is you have this tree down here, which kind of represents all the events that we received from Gradle. So you can tell, you can see all the things it's doing. It's not doing much because everything is up to date, but we can make that a bit more interesting if I run Gradle clean build, and then you would see all the things that are happening here. Okay. You can also see the times it takes. So we have a tree of events, and we're visualizing that tree, which gives you information about what is Gradle doing at this moment in time. Okay. So with that said, let me go back to the import, and because these high-level features are done. I'm going to cancel it. I have one test that goes to the internet as part of this build, and I'm not sure how well the connection is, so maybe that's why the build is still running. Okay. So let me show you basically what we provide in terms of functionality. So we can do an import. We can search for Gradle or Buildship. We get some information, and really the minimum we have to do is point it to a root Gradle project. If you do that, that's the minimum you have to do, and you're fine. You can say import or finish, and it will do the import. You can do more, of course. You can add it to working sets. If you have selected working sets, it will be added to those, and so on. If you want to, you can do a bit more tweaking. It's usually not necessary and not recommended because, as you probably understand now, what you do here is not part of your build. And what's not part of your build also means it's not shared between every developer. So the next developer that has checks out your project and wants to import it, if he has to use some custom settings here, it means something is that you need to communicate that is not part of the build. So this is really, I see it more as an experimental thing. Let's see how does my build work if I use more memory or if I use a different Java home, etc. Right? But it shouldn't be the default when you integrate a Gradle project into Eclipse. But I'm still showing it. And one thing you can do is, for example, you can use a different version of Gradle. So here we populate all the available versions. And let me go to 2.5, for example. Because by default, it's going to take the wrapper. Those that don't know what the wrapper is, it's a little tool that downloads itself, basically. It downloads Gradle. So if you're on a clean machine, you check out from GitHub, you can just say Gradle wbuild, and if you haven't already installed Gradle, it will download it and then run the build. And of course, it caches it. So if you have another build using the same version of Gradle, it will use the cached version. So really nice when you go to continuous integration because you don't have to go to your build master and say, please put Gradle on the path so we can run a build with Gradle. It's totally self-contained. It also means you version the version of Gradle with which you have built the project. Okay, so super powerful concept, and I think Maven has copied that in 3.something1 or so. Okay, so let's use Gradle 2.5. And now I'm going to the next screen and I get a little overview telling me the project structure that I'm going to import. Right? So it's just a small project that I'm using here. And you see some more info. And you can already see that it's telling me where the Gradle user home is. That's not something I specified, but it's information I got through the tooling API when I launched that build. Okay. And also, what is pretty useful, if you use an older Gradle version than what Buildship is built with, it will tell you all the things that are not supported, just to give you some idea. Okay. All right. So let's go back. Let's use the Gradle wrapper. And it will tell us what version of Gradle it's going to be using. It's going to use 2.7 because that's what that build has been specified to use. Okay. Then we can click Finish, and it's going to import the project. So what happens is it's going to go through our Gradle projects and maps them to Eclipse projects. And if they're Java projects, it will set them up as Java projects with the correct class path. What we do there in terms of dependencies, we take all the transitive dependencies and add them per project and don't export anything to other projects. Right? The good reasons for that, Netflix were the first ones to kind of come up with this, and so this works really nice now. So now we have a project set up in Eclipse, and I can compile it, I can navigate, I can refactor. It's all set up here. What I can also do is I can refresh the project, so that often happens. So you can go here to Gradle, you can say refresh project, and it's going to refresh the project. Refreshing means if you have added new projects, it will detect them and add them. If you have removed project, it will remove them from the Eclipse workspace, basically. Well, it still leaves them there, but it takes away the Gradle nature. And if the project is still there, but it has changed, it will update the project. So it will update the dependencies, it will update the linked resources, and so on. So we put quite an effort into this import to make sure you can import multiple times, you get exactly the same result. Something has changed, that change is going to be reflected in your new project configuration. It deals properly with project dependencies and with external dependencies. And whether you do a refresh or you do a re-import of the project, it's going to give you exactly the same result. Now, sometimes you have a scenario where you imported that project, you make some tweaks to it, and now you want to make sure every developer uses exactly that configuration. You can do that if you save the .project file as part of your GitHub repository, for example. When you do an import and Buildship detects that there's a .project file, it will kind of leave the project alone. It just adds the Gradle nature and says, okay, if it's there, you know what you're doing, we're just going to use it as it is. So that thing, I think that came from Itemis, since I see a guy with a red shirt there, that was a request from them, which makes total sense, right? Gives you just more flexibility. Okay, so once you've imported the project, you basically get two views right now. One you've already seen, that's the execution view. The other one is the task view. So all the tasks you see here, Buildship doesn't know about them because it goes to the build script. It knows about them because it asks tooling API, and tooling API says, okay, you have all these projects, and each project has this task. Okay, it gives you all the description. It tells you if it's a public task or not. You can filter by them. There's some options in here to order, to filter. And then you can just run something. I'm just going to run something small. Let's say I'm going to run clean build or clean assemble. And as I said before, clean is usually not something you use with Gradle. You use it a lot with other build systems because you're never sure if they build all the things that are needed to be built. But Gradle, it's not needed, but I want to force it to rebuild. Right? Otherwise, you don't see as much. So I can just select these tasks, and I can say run, and it's going to run exactly those tasks. And I see the events that are happening here. You can see it was compiling some classes, took a little bit of time. The whole bit took 3 seconds. I can also rerun that. Or I can go to the console. So here I see the console output. You also see a receipt. I'm going to say something about that at the end. Okay. So this is basically the task view. One thing I'd like to show that I mentioned before is the continuous mode. So I'm going to open that file again that I had here before. Let's say I go to this file here. Just going to modify some value. Now I can run the build and see what happens. So if I use just tooling utils build, we will see it's going to run the build. Yeah, it needs to recompile, not the production classes because I didn't change them. I just changed the test. And I should see then a okay, sorry, now I think I'm not sure what I did that it didn't run the test. Oh, I didn't fail. Maybe not sure what I did wrong. Okay, but regardless, let me show what I really wanted to show, and that is I can run it in continuous mode, and what that means is I can run it with the -t option. So if I go here, I say test -t, it means it will run, it will keep the build running after it's done. So it will keep the session open. So I'm going to run that build, -t, and when it's done, it will still stay there. Okay, so I'm going to go, whoops, to some other test. I'm going to open it here, just going to change something, let's say not equals 0, right? So you can see it has gone through everything, but it didn't stop. And the moment I saved that file, it ran another build, right? And now you can see this test is red. So this test failed, right? Now I can go in again, can make some changes. The moment I save, Gradle detects it, it will rerun and tell you if it's green or not. So why does this work? Gradle has tasks. Tasks have inputs and outputs. And if Gradle is run in continuous mode and it sees that the inputs have changed, it will trigger a new build and run those tasks that have changed inputs. Right? And that's what's happening here. I'm running Gradle test on that project. And the moment the test changes, that means the input of the test compilation task changes. It will rerun that task, which means it has to rerun the test as well afterwards. And so I can keep kind of a loop of making changes, and my build will automatically apply these changes. That works from the command line as well, but just wanted to show you that this also works through the tooling API with Gradle. Okay. The other thing I can do, so I'm going to stop that continuous build. The other thing is I can do is I can also select a test, or let's select the test class, and I can say run test, and now it's going to run that test class. And it's going to run that test class through Gradle. I think it's because I don't have the network. It's complaining about dependencies, yeah. Okay, so I'm not running in offline mode. I could run in offline mode and then it's not trying to get to the internet. But because I have not offline enabled, it tries to constantly get the latest version of some dependencies, and they're now failing because it cannot go and fetch them. So, but really the key here is to show you that when you run a build, you can also, the tests that have been run, you can run them individually and they will be run through Gradle. And so if that test belongs to a test task that depends on other tasks, those tasks will be run first. And if there are some cleanup tasks through finalizers, they will be run afterwards. Okay. So that's basically the functionality that we have available today, very roughly. There are a lot of details about this, but it's not really worth to mention here. I gave a presentation at the Gradle Summit in summer, and there we go through every little feature that we have in there. But that's roughly what we have. So we have an import, we have a task view, we can launch tasks, you see the output in the console, you see the output in the execution view, and you can run tests through Gradle. Okay, so what's coming soon? There will be a more accurate project mapping. For example, source and target compatibility are not exposed to the tooling API currently, so that will be added there as well. And also the JRE settings that you have in your build will be applied to your Eclipse configuration, project configuration. The other one, that's a big one, is the project dependency substitution. So in Gradle you have the possibility to say, I have a project with 100 sub-projects, but I'm only working on this project. And I don't always want to make sure the other projects are built as well because something has changed in my project. So what you can do is project dependency substitution, which means you only depend on the artifact created by that project. So it speeds up things if you have, in many situations. And we're going to do that in Eclipse or in Buildship as well. So that was requested by Netflix, that you can basically say, okay, I have my 10 Eclipse projects, but 8 out of them I don't really touch, so I just want to use the binary that has been created by those projects. The third one is test debugging. So you can already run tests through Gradle, but you cannot debug them through Gradle yet. So what we want to do is that you have full debug support that you know from Eclipse. You set your breakpoints and you run your tests through Gradle, but you can still debug. So basically a remote debugging session handled by the Gradle daemon will be available, and all the breakpoints and the inspection will be in Eclipse. Right, that is kind of the continuation of the test execution story. I see a thumb up. Okay, so that has been, we have been starting the specification for that. Okay, so these are some of the things that are coming soon, right? So on all of these things we have started, some with the implementation, some with the spec. Also what is already possible now is you can define custom natures and builders. That's something else that has been requested repeatedly. Okay, just to give you some resources, so the project is hosted on Eclipse, and the project itself is hosted on GitHub, the source code, under the umbrella of Eclipse. If you want to download it, you can either get it from the marketplace, so there you always get the latest minor release basically, or you can download a version that is a part of Eclipse Mars.1, which is those three where I have a thumb up. Okay, if you're interested, just a little bit of the history, because we only started this project last October, and within, or even December I would say, so within like 10 months we made it from nothing, not even a name, to full inclusion in Eclipse Mars.1, which I think is the fastest ever. But we had good help from many sides. We had good mentors, we had the Eclipse Foundation supporting us, we had a lot of support to get there. So very exciting. So if you wanted to see some history, the picture is not very representative. Buildship is not that rusty. It's pretty shiny, I would say. The last thing I wanted to mention is Gradle.com. So what we're currently working on, and there will be an integration into Eclipse as well, or in Buildship I should say, is that we're working on a SaaS-based solution that allows you to capture data about your build, put it in the cloud, and then reason about your build. You will see things that have happened, you will be able to compare things, and you will be able to share it with others. So let's say you're a build developer and you have a problem, you can just send a link to the build master, he can look at what happened on your local machine. Because what happens pretty often, this is just a mock-up, but what happens quite often is you run a build, it doesn't work, but on the other machine it works, maybe on continuous integration, or the other way around. So what do you do? And so there will be options to like pair. And you can see like if you have dynamic dependency resolution, where the green bar is, one server was using 3.3.3, the other one's using 3.3.2. Right, so these kind of things are really nasty, especially in a big project. And that will be one way to deal with these situations. So that's coming, and most likely for AmDevCon at the beginning of December it will be released. If you're interested, you can sign up to be notified. All right, that very briefly covers what I wanted to show about the state of Buildship and what's coming, and some of the background information about Gradle, so you know, the relevance of Gradle and Buildship. If you have any questions, yes?
How does the Buildship hook into the current Eclipse incremental builder support? You know, like when you save right now, when you save a source file, like a Java file, it fires out the incremental builders, which could be Java and something else. Does that also invoke the tooling API to the Gradle build daemon, or?
Yes, so currently we don't hook into the incremental compilation of Eclipse at all. So compilation still happens by that is kind of one step we would like to get to as well, is that the compilation happens via Gradle as well. It doesn't mean Gradle does not compile, but when I ran in this continuous mode, it was Gradle detecting a change and it was Gradle rebuilding the project. But Eclipse also rebuilt at the same time.
Each other, the Eclipse compiler and the Java-C compiler.
You could say they're fighting, but you could also say it in a positive way, I would say. They're not interfering with each other.
But they're both trying to write the same output file at the same time.
Yes, but not to the same location. Yeah.
Oh, so you're saying that the Eclipse set class path is putting the bin folder, is a different bin folder than Gradle?
Yes. Yes. So there's no collision between those two. But ideally what I want to get to is that compilation using the Eclipse incremental compiler happens through Gradle, so that the build itself knows to use the Eclipse incremental compiler. If we ever, when we get there, I think it's not clear yet, but that would be nice, because that's part of build logic as well, and that should be part of Gradle as well. Right. Yes?
Do you perform any resource locking or synchronization of what happens, for example, if one build task generates sources that need to be seen by Eclipse? So how do you work with the file system versus resourceable duality?
Like during import, etc., we just synchronize them at appropriate times. When you just run a build, we don't do anything explicitly in Eclipse. Right. So basically it's the same as if you change the resource on the file system by hand.
That implies you need to use F5 if you do generate sources, for example.
Yes, unless you have configured Eclipse to automatically do refresh. Yes, yes. So we don't do any. I mean, that's a good point. But right now we don't do anything explicit saying, okay, we generated these things. They're visible in Eclipse. Let's refresh them automatically. I think would probably be nice, but we don't do this right now. So whatever Eclipse does, it does for that part as well. Yes?
Building RCP applications or products also supported?
Honestly, I don't know, because I don't know how you build an RCP application. Yeah, I cannot give you the answer to that. Really, but if it works by accident, I would say. Like, we haven't intentionally added support for RCP applications. We basically intentionally support Java applications and Groovy applications. Even if you have OSGI applications, right now we don't explicitly support that, even though you can make it work. Yeah.
So how did you build Buildship?
We built Buildship with Gradle.
So it knows about Eclipse Plug-ins?
Yeah, I mean we started with Maven, and it just did not work at all or scale at all to all the automation we wanted to put in place. So we started from scratch building a Gradle build that knows to use OSGI bundles as dependencies, And it's all in our build source folder, so if you wanted to build your own project with Gradle, and it's an OSGI project, you could, all you would have to do basically is copy that build source folder, which is part of the Gradle build, and it's generic enough to be reused. But we haven't really made it public because it's just one more thing we need to maintain, right? But so we have a generic build to build OSGI bundles with Gradle, and you get all the goodies that you get from Gradle, the incremental build, you know, all the domain modeling, we have custom plugins, so it's...
The reason why I ask is I work on the Gradle plugin for B&D, which is a OSGI builder. So we have full Gradle support for offline builds. I'm trying to figure out how that interacts in an Eclipse world.
Okay.
Because right now we have our own incremental builder, so we hook in after the Java incremental builder, and then we have our own builder that builds stuff. But
Yes.
it's a separate universe than the Gradle, than our Gradle build, so they have some disconnection. So I'm trying to see what the integration is. Could we replace that incremental builder with Buildship?
Yeah.
Sounds like we can't yet because you're not hooked into the incremental builder.
Correct. Not yet, I would say. Hopefully hopefully we get there, yes. Yep. Yes?
When you say that you build OSGI applications with Buildship, does it also respect the package exports in the manifest and these additional restricted API annotation thing in Eclipse, or is it more like rough around the edges and it just does its thing for you?
It supports some of them, like the exports. I don't remember it. I mean, it was last December that we did this at the very beginning. So definitely not full support for all OSGI features that you put in the manifest file, for example. Not enough that it works for our build. Where that is on the spectrum from 0 to 100, I can't tell. But I would guess it's somewhere in the middle. So if like dependency, the ranges, etc., those things work.